Okay, so this is the 3F handout, um, which was a homework one. So we'll work our way through the problems in here, and you can correct as you go along. So let's see. First one's a proof. We typically start with the givens, and BE bisects DBA is the first given here. So let's list that. And notice step 3 is going to be the other given. So angle 3 is congruent to angle 1. We're trying to prove parallel lines. We're trying to get parallel lines, so we know that the reason down here has to end with, so we get parallel lines. So let's work our way through the proof. Now remember, the way to get parallel lines, we've got 5 ways. So we've got if corresponding angles are congruent. We've got if alternate interior angles are congruent. We've got if alternate exterior angles are congruent. And then the same side version, same side interior angles that are supplementary. And same side exterior angles that are supplementary. Those are all of our reasons there that can give us parallel lines. So these lead to parallel lines. Okay. So let's take a look at step 2. Now step 1 says BE, this line right here, this line right here, bisects DBA, which is this angle, D to B to A. So that means that it cuts that angle right in half. So angle 2 and angle 3 are going to be the same size. So that's going to follow this step. If BE is a bisector, then the 2 angles that end up being the same size are angles 2 and 3. And the rule that says if you have a bisector, then one angle is the same as the other angle, that is the definition of angle bisector. So now we know 2 and 3 are the same. In the next step, it says 3 and 1 are the same. So 2 and 3, I put one curve each there. So 1, I'm going to put another curve just like that to indicate that they're all the same. And let's see now. If 2 is the same as 3 and 3 is the same as 1, then right here, whoops, sorry. Right here, since 2 is the same as 3, in this next step, I could replace that 3 with the 2. Right? I can just substitute that in since 2 and 3 are the same. So then this line would become angle 2 is congruent to angle 1. I'm just keeping the 1 as is. So that would be substitution. So now let's look at angles 2 and 1. Okay, so angle 2 is formed by this line, whoops, this line, and this line. So that's what forms angle 2. Angle 1 is formed by BD and CD. There's angle 1. And if we slide this over, you can tell they're interior angles, and they're on alternate sides of the transversal. So they're alternate interior angles, and we know that they're congruent. Well, alternate interior angles that are congruent give us parallel lines. So this reason right here is alternate interior angles that are congruent give us parallel lines. So let's take a look at number 2. So in 2, notice there are 2 sets of parallel lines. This one's parallel to this one because of the 1 arrows. And then separately, this one and this one are parallel because of the double arrows. Okay, so let's see what we can figure out. So I'm actually going to trace out just this part. And we know that these 2 lines are parallel. And I'm going to put the 115 here. And then I'm going to slide this whole thing over. Right there. Okay, so we can figure out a lot of things from just the 115. Like, for example, this vertical angle would have to be 115 degrees. The angle next to it, let's see, 180 minus 115 is going to be 65. So this angle's got to be 65, and this angle's got to be 65. And then these four angles, whoops, would slide right over to these four angles because parallel lines make corresponding angles congruent. So those all have to be the same size. And now let me slide all that back to here, right? So you might notice that the 65 is right on top of the x plus 3z. So I'll put that, try to get that right back on top there. That's pretty good. And then I'll move a little bit out of the way here. This one was 65. Okay. Then I'll erase that 115 because it's kind of in the way. Now, if we look at these parallel lines now, let's see if I can just get those parts to slide over. Oh, I lost one of them, so let me get that one back in. That's this line. Okay. Well, I could slide the 65, or you could do a bunch of things, like let's do alternate interior angles. There's my Z shape. So this 65 and that has to also be 65. So in the picture, this one was 115. This one's 65. We slide the 65 down. This one's got to be 65, or we could do alternate interior angles right here. You could probably guess that this one's going to be 115, and you could do that a few different ways. One way would be this Z shape right there with the 115s that get formed by it. So now we've got a bunch of things that we can set up. That's a 115, not a 175. So one of the things we can set up is 5y has to be 65. So if we divide both sides by 5, we get y is 13. So that part's done. Okay. Let's see. Over here, we know z plus y equals 115. We know y is 13. So z plus 13 equals 115. So then z ends up being 102. And then up here, we know that x plus 3z equals 65. So that's x plus 3 times 102 is 65. So that's x plus 306 is 65. So that means x is actually pretty negative. It's negative 241. Which, that seems weird, but if you're doing negative 241 plus 3 times 102, you do get 65 degrees. So there are our answers for number 2. Let's take a look at 3. So 3 has a couple new terms in here. We've got angle 1 is called an exterior angle because it's outside the triangle. And if I pick angle 1 as the exterior, then the word remote means far away. So if I talk about some remote interior angles, they're the ones that are the furthest away but interior to the triangle. So not angle 2 because that's not remote from angle 1. So 3 and 4 are remote because they're far away. And if you think about remote, like a remote desert island or like a remote control, you don't use a remote control when you're up close with the TV. You use it from far away. Okay, so this would be exterior. These would be its remote interior angles. So then in number 3, it says, what are the remote interior angles for this exterior angle 5? So that's the ones that are on the inside of the triangle but far away from it, like angle 3 and angle 2. So angle 2 and angle 3. Okay, the next problem says if the measurement of angle 1 is 150 degrees, what's angle 3 plus angle 4? Okay, well, if 1's 150, then 2 has to be 30 degrees. So measurement of 2 would have to be 30. And we know that 2 plus 3 plus 4 would have to be 180. Well, since 2 is 30, then we could just subtract 30 from both sides, and you'll end up with m3 plus m4 has to equal 150. So notice, if angle 1 is 150, the remote interior angles are also 150. So let's take a look at part C that says if this angle is 110 degrees, what's 2 plus 3? Well, if 5 is 110, I'm going to do this without writing out all that detail. If 5 is 110 degrees, then 4 would have to be 70 degrees because these two together would have to be 180. But I also know 3 and 2, if I add angle 2, angle 3, and angle 4, I should get 180. But angle 4 is 70 degrees. So if I do 180 minus 70, I get 110. So that's what's left over in this triangle for 2 and 3. So that has to be measurement of 2 plus the measurement of 3. 110 degrees left over in that triangle for those two angles. Okay. For any triangle, how do you take an exterior angle and compare it to its remote two interior angles? Well, we just kind of showed that if 1 was 150, then its remote interiors were 150. If 5 is 110, then its remote interiors are 110. So you might guess that the exterior angle equals the sum of its remote interior angles. And you can prove it pretty easily. We'll do that actually. So I'll draw a triangle that looks like this. 1, 2, 3, 4. So one of the things that we can do is we can say, well, measurement of 1 plus measurement of 2 equals 180. And we also know that measurement of, that's because of angle addition postulate, by the way. And then we know that 2 plus 3 plus 4 also equals 180. And that's because it's a triangle, and triangles have 180 degrees. Well, since they both equal 180, then we can use substitution to say 1 plus 2, this one, is the same as this one. So I'm plugging this in for that 180 equals 2 plus 3 plus 4. Because each side is 180. And then you might notice, well, there's a 2 here and a 2 there. So, oh, this is substitution. And then anytime anything equals itself, it's reflexive. And then if I subtract, I've got m1 equals m3 plus m4. So that would be subtraction. And if you think about it, I just said that this random exterior angle that I drew has to equal the sum of the remote interior angles, 3 plus 4. That's what we just concluded. So it doesn't actually matter how I draw that triangle. I mean, I could draw some weird looking triangle like this. Here's 1, 2, 3, and 4. If I did this same proof with that triangle, it would be exactly the same. Nothing would change here. 1 plus 2 equals 180. 2 plus 3 plus 4 equals 180. And then you could just work out the whole thing the same way. So this fact right here is always true. And we proved it with this. Okay. Number 4. So we got an octagon, 8 sides, and then there's a bunch of info about the angles. So I'm not going to try and draw an accurate diagram for this, but I will draw a little octagon here so we have something to work with. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And we know that two of the angles are each 135. We got a 140, a 106, a 153, a 100, and a 172, and we need to figure out this angle, so I'll call that x. So first, total degrees in an octagon. Remember, octagon total degrees for an n-gon, n sides, it'd be n minus 2 times 180. Or if you did it the other way, 180n minus 360. Either one of these are okay. So let's do the n minus 2 times 180. N is 8 because it's an octagon. So this is going to be 8 minus 2 times 180, which is 6 times 180, which is, what is that? 6 times 180 is, hold on, 1080. Sorry, let me make sure. 6 times 180. I'm pretty sure that's right, though. Yeah, 1080. Okay, so the total degrees in here is 1080. So then we need to do, we know the sum of all these angles. 135 plus 135 plus 140 plus 106 plus 153 plus 100 plus 172 plus x equals 1080. So if we added all those together, I'll just tell you now, all these angles put together is 941 plus x, that's this part, equals 1080. By the way, the most common mistake people make is they forget the extra 135. Either that or they just leave out one random angle there. And so if you solve for x, you end up with 139 degrees. Okay, so that's the one remaining angle. Number 5, we've got this pentagon. It's regular, so all the sides are the same. This whole side's the same, and this whole side's the same. And it's equiangular, so all the angles are going to be equal to the angles of the pentagon. So this one, this one, this one, this one, and that one are all equal. So the first thing I'm going to do is just work with the pentagon. Let's slide this over here. And so a pentagon would, total degrees would be n minus 2 times 180. So that's going to be 5 minus 2 times 180, which is going to be 3 times 180 is 540. And since all the angles are the same, we can do 540 divided by 5 gives us 108. So each angle is 108 degrees in the pentagon. Okay, so now let me put this right back on top of the diagram here. Okay, so now we got a lot more info to work with. Let me move this 108 down just a little bit. Notice the 90 here, so this angle's got to be 90. And let me highlight this right here. So this one's x. This is a 108. This was a 108. That's a 90. Okay. Well, this shape at the bottom has 4 sides. So the total degrees for this shape is going to be 4 minus 2 times 180, which is 300. 2 times 180 is 360. And you might just know a quadrilateral has 360 degrees in it. Well, I've got 108, 108, 90, and x for those 4 angles. So 360 equals 108 plus 108 plus 90 plus x. So let's see, that's 360 equals 108 plus 108, 216 plus 90, 306, I think it is, plus x. And then if you solve for x, you get 54. So x is 54 degrees. That's this angle right there. 6. Our last problem here. So there are going to be a couple different ways of solving these things. I'll show you. I'll see if I can come up with a couple. So let's see. The hint is auxiliary or extending lines. Auxiliary means you create a new line. You can also extend existing lines. Sometimes that helps. So this should kind of feel like the problem that we did that looks sort of like this. And you could have extended a line this way or extended a line that way or even drawn like a perpendicular in. That's a pretty common thing to do. So let's play around with that a little bit. So one of the things I see is maybe if we extend this one down here, that might be useful because then we've got this triangle to work with. Let's see, this angle's 98. This whole thing's 180, so 180 minus 98 will be 82. So this angle right here is 82. What else? If I extend these lines, notice these are parallel. So the 72 right here, we could do alternate interior angles to get this 72. Like notice the Z shape right there for alternate interiors. Or you could slide this 72 over to here for its corresponding angle. So then we could figure out Y has to be 108. Okay, so here's another one that you might not see easily. I'll use green highlighter for this one. This, whoops, that didn't work. This line and this line are parallel because you can see the arrows here and here. And here is a transversal right there. So you might be able to notice this C shape right here with the 72 up there. So this angle's got to be 72. And now we can work with this triangle that's got an 82, a 72, and a Z. So 82 plus 72 plus Z equals 180. And if you solve that, you end up with Z equals, let's see, that's 154, is that 36? 26. So Z is 26, and Y is 108. So let's see if we can do this another way, because that way uses some hard to see tricks in there. So let me erase all this and see what else we can come up with. How about we do, well, first, let's just look at these again. I think the easiest way to get Y is to just look at this. If that's 72 degrees, oh, and the top and bottom are parallel here. Or sorry, the left and right lines are parallel. If that's 72, this angle and this angle are same side interior angles. And we know parallel lines have to make same side interior angles supplementary. So this would be 108 minus 70, or 180 minus 72. So 180 minus 72, 108. So right away we've got Y is 108. And then I'm going to try drawing in a line that's perpendicular to things. So I'm going to draw that one in here. So basically I'm doing slope triangles. So it'll be, the top and bottom are parallel. So if it forms a right angle with one of them, it's got to form a right angle with the other. If I know that this angle is 108, I can figure out that the one next to it would be 180 minus 108. That'll be 72. I've got a right triangle up here. So this is 90. This one's 72. So 90 plus 72 is 162. So that would make this 18 degrees. And then I've got an 18 degrees and a 98 degrees. So this angle let's see, 18 plus 98 plus, I'll call that x. X will be 180. So let's see, 18 plus 98, 108, 116 plus x equals 180. So then that will be 64 degrees. And I know that 64 plus 90 plus z have to be 180 because it's a triangle. So that's 154 plus z equals 180. So z ends up being 36. Okay. So hope that helps a little bit. Oh, sorry, not 36. 26. My bad. Just seeing if you're paying attention. There are some other ways of doing this too. I've seen in the past some students will create this line right here. Whoops. And then you can use this Z shape to get that this is 72. So they're creating a new parallel line. And then the one below it ends up being, let's see, 98 minus 72 would be 26. And then you've got this Z shape right here. So this would be 26 also. So there's a ton of different ways of trying to do this. I've even seen some students extending this line and then sort of working their way around this shape somehow, and then working their way into that little tiny triangle down there. So there are lots of different ways of going about this. All right, I hope that helps a little bit, and I'll see you guys soon.